Right. So first question to Neve, right? 10 push-ups from one finger, okay? From one finger, like Bruce Lee. Okay. We understand. We understand. Uh, we understand. When we have sine 4 theta, right? We have sine 4 theta, right? Write this. Write this in terms of theta. I'll give you 30 seconds, work it out, and then let's see. Sine 4 theta, write in terms of theta. So this is one of the questions you get in the exam in different ways. So this is a must knowledge you should have. Sine 4 theta in terms of theta. So that means you cannot have you cannot have 4 theta, 2 thetas, 3 thetas in the expression, only theta. What do you mean by that? That means sine theta can be there, cos theta can be there. So only functions in terms of theta only. What school people are doing now, specialists?
Just those partial fractions.
Oh, they did final fractions.
Just those
Okay. Done. Done. Okay. Yeah. Oh, hold. Yeah. Go ahead.
Um,
Hmm?
from the end.
No, no. Tell me the steps.
And the first we use like the double angle formula.
Double angle formula. Like this. Okay.
Throughout,
Eh?
take the cube out and then do the double angle formula and sign.
Okay. I have this, right? So now what is the next step?
You see the two?
Yeah.
You need like put that out and put a bracket. Yeah, yeah. Then do the double angle formula on sine 2 theta again.
Sine 2 theta, this one. What is that? Okay. Mm-hmm.
Cos 2 theta.
Mm-hmm.
Cos square theta minus sin square theta.
Mm-hmm.
Like that.
Then you write this way. Yeah. Okay. Good. He saved his push-ups. Right. So sine 4 theta, you write it in this way. Okay. Next question. Next question to Aston. Expand cosine theta plus alpha. right? Okay, what is the answer?
Cos theta multiplied by cos alpha
Cos theta multiplied by cos alpha.
minus sin theta multiplied by sin alpha.
Okay, good. Next question. Simplify sin 5 pi divided by 6 plus sin pi divided by 12. Yeah, this will go to Pranav. Who's born? Yeah, you're born, right? Where is Sumit? Hmm?
I think it's coming back next week.
Oh, Sumit is online. Yes, Pranav. T. Hmm? Push-ups. In front of girls. That's the best part.
So you have to do it.
Hmm?
You have to-
And who did this? Harkit, you did? Yeah. Misha? No? Did. What is the answer? Say it again. How do you get it? Mm-hmm. Okay, so what you're saying is you did sin what? Pi minus pi divided by 6, right? Yeah. Then this one is sin huh? Pi over 3, pi over 4. So this one is going to be now uh, sin minus sine pi divided by 6. Am I right? Pi minus pi divided by 6. What is that?
So, above.
Huh?
I think you unit cycle in second part.
Yeah. Second quadrant, all
It's
sign
plus.
positive. Sign stays sign? Yes. What about this one? Double angle formula. So double angle formula, sine A minus B. So that's going to be sine pi divided by 3, cos pi divided by 4, minus cos pi divided by 3, sine pi divided by, agree? Okay. So what about this guy now? So this guy is going to be sine pi divided by 3 is square root 3 divided by 2 times 1 divided by square root 2 minus this is going to be half. This is going to be 1 divided by square root 2. So this is going to be sine pi divided by 6 is half. Right? So you get, there is a plus here. Yeah, you get plus minus everywhere. So you get now common denominator is set for 2 square root 2. So you can have square root 2 here plus square root 3 here minus 1 here. Is that the answer? All right. You have the rationalized version. That's fine. Okay. All good. This question. Go to Nilendi. Right? My friend. Simplify. Simple question for you. Sin A plus B plus sin A minus B is equal to sin A plus B minus B. Okay. So, okay, that's fine. Quickly, this question too. Right. Praveen. Tan A plus B. Knowledge is a spontaneous thing. Spontaneous thing. What is spontaneous means? Spontaneous means like this. Okay, tan A plus tan B, 1 minus tan A tan B. Okay, Praveen. So now with this, you have to remember this. When you have tan 2 theta, so that means B becomes A O, both the same, right? So it's going to be tan theta plus tan theta divided by 1 minus tan theta tan theta. So you should be able to derive this. So it's going to be 2 tan theta divided by 1 minus tan square theta. So you should be able to go from here to here, right? Good. Okay. Yeah. Okay. Next one. Let P vector is equal to M1 I hat, M2 J hat plus M3 K hat. Find P dot P right and P dot I hat J hat, P dot J hat J hat. Simple question. Done. Okay. So P dot P, you should get M1 squared plus M2 squared plus M3 squared. Check your answer. P dot I, okay. So this should be M1 J hat. This should be M2 J hat. Correct? So this guy is just that. Then this guy is copied. Right? And you saw this kind of a thing. So this shape you saw in vector resolute. Vector resolute. Okay, this question. So O, A, B. So this vector is A vector. This vector is B vector. Okay. O vector, O vector, A vector, B vector is given to you. O is the origin, right? So O means origin all the time. Find the area of the OAB triangle using vectors. Okay, good. Okay. Okay, let me tell you what you have to do. Now, suppose this is going to be C point, right? So OC OC distance, or maybe I would say OC distance, right? OC distance you guys did in this way. A vector dot B hat. Now we know that B hat is not given, but we will work it out later. Then that. Then OC vector you can do having that B hat outside. All right. So that is one thing. Now you guys use Pythagoras theorem here. So AC squared is equal to A vector, which is OA squared, minus OC squared. OC vector or OC distance squared, or OC distance squared. So this is going to be A vector squared minus OC is going to be A vector dot B hat squared, and that is AC squared. Now area would be half times base is going to be B vector hat, that is what Adi was missing, multiplied with then AC. AC is going to be square root of this dude. So square root is what Kanishka was missing. Now when I got the answer, I was carefully looking into it. You saw that. I saw that Adi was missing this one. I don't know, because your grader is going to be a very experienced guy. He will see everything. So it's not right. And then Kanishka was missing this square root. Why? Because he forgot. Because he calculated AC squared, but when he was copying, he forgot. But there is no mercy, right? So anyway, that's the answer. Okay. Did I do cross product with you? I did cross product, right? Yeah, but I introduced cross product, ne? But I didn't tell you how to find the cross product. That's fine. Okay. Look at this picture and see whether this is what I taught you. Look at this. This is A vector. This is B vector. I'm going to make a line from here to here. And I'm going to have a thing here. And this is going to be 90 for both. Now, this vector I wrote as A vector dot B hat, that I discussed, I think, in the class. Then this vector is nothing but A vector cross B vector. A vector cross B vector. Yeah. I did that right? Hello, yes or no? Yeah. So A vector cross B vector is perpendicular to A and B both. It's like this. So A is here, B is here. That A cross B is like this blue pen. A is here, B is here. So A cross B is this guy, the vertical guy, A cross B. So that A cross B guy is perpendicular to this vector and this vector both. That's what we understood, right? So it's very hard to draw, but you understand the picture now. Right. So definition of cross product is this. Oh, 1 second, stock. Yeah. So definition is A vector cross B vector is equal to A vector mod B vector mod sine theta. What is the theta? Theta is the angle between these two. Okay, my friend? All good? Now, this is what you know. My question. Find the area of the previous triangle using cross product. I'll give you what something. Okay. So see whether you have this. Um, so my intention is area is equal to half times B vector magnitude times AC distance. AC distance. So AC distance, I'm going to write in this way. Now, if this is theta, I'm saying if. That's right. Oh, hold on, how you did that?
Look at the previous answer. Weird.
That's pretty impressive. So he took the previous because previously we found the area using dot product. So then he thought, okay, so let me start from there because we are going to find the same area in a different way. See, look how the brain works. Now your integration doing right now is not going to work here, my friend. Okay. If you don't want to listen to me, that's fine. I'm very experienced. I'm very experienced. If you show me this skill, I don't care about the syllabus. Literally, I don't care. Because the reason we have the same journey, same expectation. So that's good thinking. Okay, let's do this. AC distance, right? Okay. So if this is theta, I'm going to get, look at this, A vector cross B vector is going to be A vector magnitude, B vector magnitude, sine theta, and there is a direction. You with me? That direction is the perpendicular direction. because this whole thing is a scalar. This whole thing is a scalar. The direction is the perpendicular direction. The direction is the perpendicular direction, right? Okay. So now you know that if you get the mod here, what will happen? Then this direction guy is gone. Now, if you really think about grade 7 math, this AC height is A vector magnitude sine theta, isn't it? Sine theta. Now, if you look into this cross, A sine theta is there. A sine theta is there. But this B magnitude is extra, isn't it? So now what we do purposely, we force this B to be 1. So how do you force this B to be 1? This guy. So we force this B to be 1 sine theta. Then I can do this. See, I introduce B hat there. Then mod D is going to be 1, isn't it? You okay with me? So now you can see A sine theta, which is the part we need there, which is AC, we got. So this is going to be half B vector magnitude. Now AC distance I'm going to write A vector cross B hat mod, game over. Is that clear? What he did, he didn't have that vision. That's okay. But he thought intelligently, okay, so same A can be here. So then let me start from the previous answer and then derive until I get a cross. So then he saw cos. So he did some, you can see if you look into that, his algebra is perfect. So that's why I'm so exciting. Because when I see that algebra, I know when he's writing the paper, no complaint. Because I can see like maybe it's 10 months ahead of what you do. I should be able to. So that's the exciting part. Okay, so now anyway, now you got it. Okay, Austin? Okay, good. So now we defined this cross product and then we found why, how to write the area in terms of the cross product as well. So now final thing, be careful with these B hat and B vectors, okay? Be careful with these B hat and B vectors. You have to use them purposely, okay? So if you do this one in the exam, it should be like this, but you do this one in the exam, it's all gone, okay? But anyway, this lesson will be doing on Wednesday class. Wednesday? Yeah, Wednesday class. But after complex numbers, this is the lesson I'm going to start. All right? So theory, I will revise that for you. Okay. This I will do with you. Write OC vector in terms of A and B. Write OC vector in terms of A and B. Okay. So now the way it is given to you, AB I'm going to write B minus A. That we know, right? That we know, AB vector. So now you have to understand AC vector is going to be M times AB vector. M times AB vector. So this M is what? A constant. M is a constant. So this relation tells you that ABs are collinear. This relation tells you that A comma B comma C are collinear. Collinear means what? On the same line. Coplanar means what? On the same plane. Right? Okay, so that is collinear. So AC, you can write now M times B minus A. Actually, yeah. AC is equal to M times AB. Okay. Now, using vector addition, right? Using vector addition, you write OA vector plus AC vector is equal to OC vector. So now OA vector is A vector plus AC vector is M times B minus A vector is equal to OC vector. Right? You understand what I'm doing, right? Yeah. Then OC vector is equal to, so now I'm going to factorize. So if I take 1 out, I mean A out, so it's going to be 1 minus A, 1 minus M, A plus M B vector. So that's answer. So this is the revision for collinearity. Collinear means on the same line. Now we never remember these things, but we should be able to construct when we have questions, which we are going to do in the future anyway. Good. Right. Okay, go to this assignment. Let's do question number 1. Let's do question number 1. Say it again. A dash. Which dash? No, 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 comma, comma, comma. this is now Z1 is equal to M divided by 1, 1 minus I, right? 1 minus I. So we know that we don't like having these things in the denominator. So what you do, you multiply by its conjugate. So if you multiply by conjugate, you get x squared plus y squared. So it's going to be 2, right? M 1 plus I. So similarly, Z2 is n divided by 1 minus 3i. So this you can write n divided by 1 minus 3i multiplied by 1 plus 3i divided by 1 plus 3i, and that is equal to 10, right? So 10 here, check my calculation, 1 plus 3i. So now it is given to you that Z1 plus Z2 is equal to 1. So what you do, you have to add these together, and that is going to be 1, right? So now if you look into this left-hand side and the right-hand side, if you look into this left-hand side and right-hand side, this is a very famous situation in past papers, this methodology. Now, you are going to group the real terms here, which is going to be m divided by 2 plus n divided by 10. And you are going to group the imaginary terms here, m divided by 2 plus 3n divided by 10. So now you can see the real terms and the imaginary terms separately. And that is equal to 1. Now 1 is a real term, but you know equal means equal. Equal means equal, meaning if you have complex number, if you have a real part and the imaginary part in the left hand side, you are expecting that in the right hand side as well if it is equal. So you are expecting this, right? So now what you can do, you can carefully match this with this guy and this with this guy. So when you do that, you get a simultaneous set, which is going to be 1 here, and then this is going to be this here. So now I'm not going to do that further. Simultaneous is solve it, you get the answer. Okay. Let's do question number 2 now. Let's do question number 2. Start question number 2 now. Okay. First of all, Z times W. Z times W is multiplication, right? So it's going to be XA plus IBX plus IAY, then minus YB. So this is going to be now XA minus YB plus I BX plus AY. That is going to be CW. That is going to be CW. Right? So now real of that. So real of that would be, that is super simple. YB should be is equal to 0. So you need to find now Y is equal to AX divided by B. And importantly, you have to say B is not equal to 0. Reason, it blows up. Goes to infinity if that happens. So you better have that. Let's do question number 4 quickly. For 4, you have 1 divided by 1 plus I. Find the exact value of Z mod Okay, I think z is 1 divided by, right? Okay. So z is equal to 1 divided by 1 plus I. So you have to understand, then z conjugate is going to be 1 divided by 1 minus I. Is that right? Uh-huh. Are you sure? Are you sure? Let's see. Okay. So this is going to be 1 minus I divided by 2. So from here, you can find this is going to be 1 plus I divided by 2. Okay. Do it in the safe mode because the I was in the denominator, right? So x plus iy conjugate is x minus iy, right? So I took that into the numerator so that we are in safe. So now z mod is going to be z bar square root of that one, we know in theory. So this is going to be 1 divided by 4. This guy is going to be x squared plus y squared. It's going to be 1 squared plus 1 squared, right? Square root of that. Check my calculation. So if that happens, you get 2 divided by, so 1 divided by square root 2. Okay. Now, so we know that z is going to be 1 divided by 2 minus half I. So arg of z is going to be what, guys? You have to understand this is nothing but tan inverse y divided by x, and that is nothing but minus half divided by tan inverse. So tan inverse minus half divided by half. So if that happens, it's going to be tan inverse minus 1. Answer is tan inverse minus 1 means pi divided by 4. 3 pi divided by 4. Negative pi. Negative 5 pi divided by 4. That is right, pi, because you know the principal argument concept as well, right? So you can't pass pi. Good. Let's do question number 5. Let's do question number 5. Yeah. So consider this. Express z plus 1 mod in the form a b plus cos theta, a b plus cos theta, the square root, a comma b are positive integers. Okay, so z plus 1 is equal to cos theta plus 1 plus I sin theta, right? C plus 1 mod is equal to, you can see these terms, right? So this should be cos theta plus 1, the whole thing squared plus sin squared theta square root. Right. So now you get cos squared theta plus 1 plus 2 cos theta. What is the format we need? Yeah, let's see. Plus sin squared theta. Now you will understand why I have this and this, right? So that's going to be 1. So 1 and 1 is going to be 2 plus 2 cos theta. Now 2 plus 2 cos theta. So now what we can do, you can take 2 out internally and then write this. Right? So yeah, so A is going to be 2 here. Then B is going to be 1 here. A is going to be 2, B is going to be 1 here. Okay. Okay. So second. Right. So let me discuss another important theorem with you. Conjugate root theorem. Write down with me. Conjugate root theorem. Conjugate root theorem. So suppose this is the theorem, okay? Suppose P of Z is equal to z to the power 3 plus A, B z to the power 2 plus C z to the power 1 plus D, where A, comma B, comma C, comma D are real constants. I'm emphasizing this, real constants. A, comma B, comma C, comma D, A, B, C, D are real constants. And Z minus I, for example, is a root. Suppose. Suppose z minus is root. So conjugate root theorem tells you this. Now, we know that az3 plus d, you can write this one as z minus I. And then the other factor is starting with a z to the power 2 plus goes on like that, right? Now you can see the highest order is 3, 1 here, 2 here. So that makes the highest order, right? This theorem tells you this. This theorem tells you if A, B, C, D are real numbers, conjugate of this one is another root. Meaning, if this happens, you can write z minus I, that's the given factor, then conjugate of this one plus I. Conjugate of this one is going to be a root as well, right? So conjugate of z minus I is a factor. That's what the question, that's what it says. Okay. Let's do example here. If P of z is equal to c to the power 2 plus B of z plus c, where B comma c are real, if P of 2 minus I is equal to 0, find B and C. Okay. Go. Okay. What is answer? So now the way it is given to you, right? The way it is, this is 2 minus I, right? So z is equal to 2 minus I, right? Yeah. Z is equal to 2 minus I. So if z is equal to 2 minus I, from here you can make a factor. You bring everything to the other side. Minus 2 plus I. So you write this one in this way, z minus 2 minus I. So that's the factor. Do you see this one? So this is the factor now. That's how you make factors, math methods. That's how you make factors, right? Like if you forgot x squared plus 5x plus 6, if the factors are 2 and 3, I mean, if the solutions are 2 and 3, you make a factor by bringing this one to this side, x minus 2, x minus 3. So when you multiply these two factors, you can see you recovering this, right? So you can make factors from the solution. So now this tells you that P of z is equal to z to the power 2 plus bz plus c can be written as z minus 2 minus I, isn't it? Z something, right? So now the question is given to you that these are all these are all these are all real numbers. So you are going to do plus I. You are going to do plus I here. So we use conjugate root theorem. So this is very easy when one root is available, you can find the other root simply by taking the conjugate. So that's very easy. Okay. Let's think about another question. So write down this question with me. P of z is equal to z to the power 3 minus 3z squared plus 5z minus 3. Okay. Uh, z minus 1 plus square root 2i is a factor of P of z. Factor of P of z. Okay. Question is, find the other linear factors of P of z. Okay. Do that question. So, observation. All real. All real means you can write this one. One factor is given to you, right? Z minus 1 plus square root 2i. One factor is given to you. The other factor is going to be z minus 1 minus square root 2i. Look at the beauty here, see? Conjugate, right? Now, observe z to the power 1, z to the power 1. Here, z to the power 3. Now, you need to have z here because you can see z to z to z is going to be z3, right? So now how do you write a polynomial? The next term should be one order less. So if this is z to the power 1 here, the other one you can say alpha, right? So now you need to find alpha now. So now the next one. Next one is, you can see this minus 3. You obtain this minus 3 from here to here to here. That means when you multiply this with this guy and that with this guy, will give you that minus 3, right? So you can say minus 3 is equal to square root 2i minus square root 2i times alpha. So I is minus, so minus minus is plus. This is going to be 2 alpha minus 3. So alpha is equal to minus 3 divided by 2. Yeah. Yeah, if your multiplication is right, check my multiplication, my values. So alpha is equal to that. So I'm going to write this one to be z minus 3 divided by 2. Check my algebra. I think it's right. That's how you do it. So that's, what do you call it? Polynomial division or something in the methods, right? So that knowledge can be used. The only new thing you learned today is the conjugate root theorem is the only new thing you learned, okay? Yeah.
I don't relate the long division.
You can, obviously you can do long division, but that takes forever, right? Okay, let's do this one. Solve P of z is equal to 0 to the power 3 plus 3z squared plus 7z plus 5 is equal to 0 for me. So now this is a polynomial, right? So you need to somehow find the first factor. Factors are not given to you. So you need to find the first factor. So the way it is given to you, right? When z is equal to minus 1, it would be 0. So that means z here, z is equal to minus 1, right? So z plus 1 is a factor. C plus 1 is a factor, right? So once you find that one, so you can write the first factor is z plus 1, right? First factor is c plus 1. Now, there is no way you can find the conjugate of it, right? Because you don't have a imaginary term there. So what you do, you have to find the other one. So to find the other factor, so luckily this is to the power 3 here, and then this is 1 here. So we understand this should be 0 to the power 2 now. Now easily you can find it from the long division. So if you do that, your answer is going to be 0 to the power 2 plus what? 2z, yeah? Plus 5, right? So then how do you get the roots from here? How do you get the roots from here? One thing is you can do the complete in the square, and then you can use difference of two squares, right? So this is going to be z plus 1 square plus 5 minus 1 plus 5 minus 1 is what? 4, right? So this I'm going to write as minus 2y square. Agree? Minus 2y square, right? Now you have to understand when you are in grade 10, I mentioned to you that in the completing the square methodology, that minus sign is very important. The purpose of that minus sign is doing the difference of square, right? So now we are easily doing that in here. So now you get c plus 1, z plus 1 minus 2y, z plus 1 plus 2y, and that is difference of 2 square. So that's the answer. Now, when you really observe this one, you can see this guy and this guy are conjugate factors. So why you got conjugate factors? You go back to the polynomial and see. You can see 5, 7, 3, 1. They are real. So indeed, you are expecting to have that. Okay. Okay. So